Okay, everybody, welcome to wasmCloud for January the 13th, 2021, where we're trying to enable developers to build their functions and services in WebAssembly and run them everywhere. We've got a few new folks joining us this week. Gustav, can I turn it over to you for a quick intro?
Sure. My name is Gustav, and I'm here as a curious contributor, hoping to help out with this project. I work professionally at a consultancy agency in Sweden, and I guess that's it. This is all very new to me, but I'm very grateful to be here with you guys, and you seem like really cool people. So, yeah.
Collaborate get you everywhere. Awesome, welcome. And Daz, you want to say hello and introduce yourself quickly?
Hey folks, thanks for including me. I'm a former Googler, now early retired, interested in blockchain, Kubernetes, wasm, Rust, Golang. Played around with waPC stuff and protobufs on a personal project. I'm super interested to see where this goes.
Okay, that's awesome. And with our new desire, we're going to go ahead and get started with the demo. Phil Keaty has been with us for a long time. He works on a lot of different technologies that we use in the stack. And today he's going to do a quick demo and walkthrough of the new waPC CLI. So Phil, turn it over to you, buddy.
Yeah, I guess to take a step back though, for folks that are new to waPC or waPC or whatever you want to call it, the first step in waPC or waPC is to solve for really an n-by-n problem with polyglot, right? So there are multiple languages we want to write WebAssembly in, and there are multiple hosts that we want to consume WebAssembly from, right? So, there are going to be standards to address this in the future, but there needs to be some tooling here and now. And I think this is what a goal was. I have an internal project, just so you know, I actually work for Capital One. I'm actually about to leave Capital One here shortly, but in some of the stuff that I've done internally to Capital One, a lot of it was WebAssembly based with Kevin Hoffman. Kevin Hoffman and I joined forces to kind of build this common layer, if you will, for invoking logic inside of WebAssembly. So with that backdrop, where waPC kind of starts is just passing back and forth arbitrary byte arrays, right? And so up until now, we've left it up to the developer to make sense of that byte array. Like Daz just mentioned, he's using protobuf in his side project there. So, it's kind of up to you to figure out what you want to do with it, but that can kind of lead to some developer friction. And really our goal is to make it so you don't even have to deal with that or solve for that in your project. And that it's almost kind of like our vision is like gRPC, but for WebAssembly, right? Like you generate the code, you get all the glue, and you're off and running, right? So to start off, we have this new CLI that's goal is to do just that, is to provide zero friction. And I'm gonna start sharing my screen here. So I've prepared a little bit of a small demo here, and the use case is that I want to build a very simple rules engine using WebAssembly, right? And the cool thing about this is, in theory, WebAssembly, if I want to change a rule, I can just reload that on the fly and bring it into production without having to shut down services or go through that whole motion, right? So it's a sweet spot for WebAssembly for sure. So getting into some of the new tooling, one of the things we have, and I can make this visualize a little bit better.
Just to make sure everybody understood that, you've got your CLI here, and your demo is that you're going to build a rules engine for us. Is that right?
That's right. Yep.
Okay. Just want to make sure everybody was kind of following along with what you were trying to show.
Yep, you got it. So much like protobuf or gRPC, there's kind of an IDL associated with it. And so, in some of the internal projects that I mentioned, we started out with looking at protobufs and various ways of serializing data. And we probably won't get into the rationale for doing what we did here today, but we do intend to document it in the near future so that it's understood. But basically what we're doing here is instead of using protobuf, what we're doing is actually using a spec called message pack. And there are a couple reasons for that, but in our usage of it, it actually seems to be quite a bit faster than protobufs. There's less CPU horsepower being devoted to compression, which is a little bit of a trade-off there, but it gets the memory passing around a lot quicker. So the problem with that, though, is there's no real IDL for message pack. So we decided to create one, and we did it in such a way that was, I guess you would say, fit for purpose for WebAssembly. So, if you look, there are numeric types here that are aligned directly with WebAssembly. And so the basic structure here is you define your interface, for what your module is going to implement, any methods inside of here, and inputs, outputs. So in this case, where we're doing a rules engine, you want to input in your facts. And I have a structure down here that represents your facts. It's very simple. Pretend we're issuing loans. Maybe what we want to do is just make sure that your income is at a certain level and that your credit score is at a certain level, right? And then the business rule engine, its responsibility is returning an array of decisions as to why you might not qualify for a loan. If it returns back an empty array, you're good to go, and it should approve you for that loan. So that's the basic demo here. Obviously, in your use cases, you can expand upon the data types. You can nest them. You can make fields optional, just to give you a sense, by putting things like question marks after them. The brackets represent lists or arrays, and you can even do things like maps, like so. Right, just to give you a sense. So all these rich data types are able to be expressed in this format that we have here, and we call it WIDL. So it stands for WebAssembly Interface Definition Language. So now that we have that, we're going to take a little bit of a step back, and the first step to any CLI really is to bootstrap or create or initialize a new project, much like something like a Yeoman or something along the lines of those tools, right? So the unique thing here is, when you say I want a new waPC project, the next argument here after the new is the project template I want it to use. And those are typically going to be language specific. And it comes, the waPC tooling comes with out-of-the-box templates for Rust, AssemblyScript, and TinyGo. So what I'm going to do here is go to my command line and just go ahead and drop those 3 waPC new commands. Interesting. For whatever reason, cut and paste is not working.
Phil, now this this thing that we're creating here, this initial piece, what would you refer to this as? So would this be like a scaffold, or what's the language for the artifact? Okay, so we spit out. So we start with our schema and our design, and then we run this through, and then we're going to say we've got a scaffold here of what's going on. Okay.
Yeah, another word for what's going on here is essentially contract first development.
Exactly. So now that I've run those 3 commands, I've got essentially a scaffold of my rules engine for AssemblyScript, Rust, and TinyGo. So initially, you're going to get a very simple WIDL file with like a hello world, basically, in each one of these things. So before I start putting in the business rule thing in here, I want to show you essentially what this would generate without making any kind of changes there. All right, so what we have here, and if we look at the code gen, so what that did, part of the project structure is also to include a code generator, right? And so there's a configuration file that gets laid out. It is laid out for the language that you are building in. So there's AssemblyScript things that it will build for AssemblyScript, and so on and so forth. But when I run the code gen, or really run the make file, you get a make file for each of the languages that you're generating for. And it's consistent, right? So if I say make code gen, it's going to make run the code gen for that language. If I say make build, it's going to do the language specific things for that language. So in Rust, it would do cargo based things, and so on. I think you get the point. So when I ran the make, it found out that there were some files it needed to generate. which a lot of it is, here's the glue code that has to do with all the message pack stuff and the interchange and passing that back and forth. And then here's kind of the scaffold part. So this only gets generated if this file does not exist. And so from here, if I wanted to implement the hello world, you know, I do the assembly script way of doing that, and I can, there you go. I now have hello world and assembly script. So that gives you a sense of what you get out of the box when you first run the tooling. But realistically, it is contract first development. So what I'm going to do here is I'm going to clean this up and get rid of those files because those aren't really what I want. And what I'm going to do is copy my rules engine WDL into each of the projects I generated. So copying over the WDL in each one. All right, so now my WDL is updated for each of these guys, right? And you can see, just to go back, actually I need to generate it first. So I'm actually going to generate each language now. So this is, in each language, going to get me a scaffolded business rule engine now. You'll notice it's obviously pulling down the waPC guest and so on. The developer almost doesn't even have to know that WebAssembly is in play here. It very much resembles existing development paradigms that people are very familiar with. So while that's cooking, because it's Rust rather, we'll get the next one copied. And one thing to point out, I mentioned the make file is almost like your contract for building this thing. Each of the languages will drop the .wasm file into a directory called build. So here you'll see rules_rust.wasm. So I'll move on to the assembly script, and it's very much the same process. It's just geared toward assembly script instead. So in this case, it's generating an assembly script module, an assembly script scaffolded index.tx, which is like your entry point, if you will, and it compiles it. And there you go. So there's a rules._as for assembly script, and that's that. And then finally, here's TinyGo. And TinyGo compiles the fastest of them all because it's Go. But anyhow, same result. You have a rules_tinygo.wasm. So, all right, well, where do we go from here? Here's where you imagine I take like the ingredients of the cake I just put together and it's unbaked and I stick it in the oven. And then I like magically go to a second oven and like pull out a fully baked cake. So that basically is this rules demo project here. And you can go grab it. It's at this repository here underneath waPC, and all the stuff is built out. I didn't go ahead and build the rules engine for each language. I went ahead and just did it for assembly script. I'm a big fan of assembly script, but let's just go kind of peek around in that repository real quick. So again, it generated all the glue code associated with being able to invoke that decide function, right? Passing in facts, getting an array back of decisions. Very simple, right? I've just added a couple little assembly script interfaces and classes here to implement a very basic rule engine, right? And then in the index.ts, I've implemented my decide function and wiring up all, initializing the engine, creating rules, adding them to the engine. And then all the decide function really has to do is call .evaluate, passing in the facts, and evaluate does return the array of decisions. So all that is kind of deferred, if you will, to that really basic class, okay? So finally, we got to put some, look at what the rules do. So the rules are very simple. It looks at your credit score, and if it's lower than 400, it'll say, I'm making a decision that your credit score is too low. And very similarly, looks at your income. If your income is below $4 grand, it'll also say you don't, your income's too low, right? So that's really basic. I already have this pre-compiled. It's dropped again into this build rulesdemo.wasm. And also what I've done here is encapsulated this in a very basic Go or API, if you will. I'm not following very good practices here. Like it does handle reloading, but it doesn't use atomic pointers to the rules engine and so on. I will enhance this demo to do it probably the more best practices way, but it does work, at least for demo purposes. So that is running right here. And in the README, it does contain a curl that you can send to this.
Phil, can you take just a quick second? I'm not sure if you skimmed over it or not, but you've got a host runtime written in Go, right? And that's
right.
And that's using the waPC host runtime library for Go, right?
Yep.
Okay. I just wanted to make sure that everybody is aware of what's going on. Is that we have both a runtime written using a waPC library, and then the WebAssembly modules compiled to wasm also using a waPC library.
Yep.
Okay.
Thanks, Kevin. And I did blow right by that. So very important thing to call out. And I just decided to do this in Go, purposely not showing as much Rust here because Rust is like a first-class citizen of supporting wasm, right? And we want to show that you can do things outside of the Rust world and still leverage WebAssembly. So yes, this is the library that Kevin was referring to. This is the Go version of the host library. There's one for Rust as well. We have a browser-based one. Probably more to come for sure. And this is what I meant by the n-by-n problem. So anyway, here, yeah, to get back to this, we have two URIs that this exposes. So one is obviously the decide call or the decide URI, and the other one is to just trigger a reload, right? And the logic here for decide handler just literally calls into the rules engine. This is also generated code, by the way, from the code generation tooling. So I'm able to generate code that can be leveraged in the host as well. And that is what this code is doing. So the decide function is.
So on that point real quick here, when you think about, right, so it's does it make all the calls bidirectional, or is there any sort of directionality when you write your schema.whittle? Is there any sort of directionality that you would make for the calls, or does it just do them both bidirectionally?
It does them both bidirectionally, and I think we want to expand upon that or enhance that so that you can mark a particular method saying this is only going to be in the guest, or this is only going to be in the host. And so those will be some enhancements coming shortly to enhance the code gen so that you can actually express unidirectionality for certain function calls.
It's probably worth pointing out though that the way, like if you've ever generated gRPC servers and clients, you'll be familiar with the concept of the bidirectional generation, because all the gRPC code generators generate both server-side and client-side stubs, whether you use them that way or not.
Hey, Phil, this is Daz. Actually, that's a good point. It's very familiar from a gRPC development perspective. Phil, can you show where you're instantiating the rules engine in the Go host? I can see the handlers, and you've got the rules engine there already, but where's that get created?
So that's where it's getting invoked. I will show you where it's getting kind of initialized, right? So can everyone hear me okay, or is there too much background noise?
No, it's fine. It's a little bit noisy, but it's fine.
Yeah,
life goes on. That's exactly what I wanted to see. Thank you. Okay,
yep.
Yeah.
So yep, the code's loaded from the wasm file, waPC new. So that's kind of like, again, just passing the arrays of bytes back and forth. And as soon as you take the instance of one of those things and throw it into the generated code, so it's just package.new, pass it an instance. Now you have like the equivalent of the gRPC client, if you will. And then I make use of that gRPC client right here. Just again, not the best idiomatic Go code for writing a REST API, but serves the purpose for the demo. But calls decide, facts are just parsed right in from using JSON straight from the request. And I get this array of decisions back, which I'm just, marshaling back to JSON and sending back an OK response. So that's all there is kind of to this. And just to give you a peek.
One follow-up question. I apologize. I'll be quiet after this. So following up on the gRPC bit, with gRPC, when you generate the server, you're pretty much writing boilerplate, and you end up with a generic gRPC host that's running the server-side implementations. It seems here that could apply here too, that you're writing what's essentially boilerplate for some, in this case, Go host, and then you're going to write a client that calls against it. But this Go host seems to be kind of generic, right? I almost want to get this auto-generated for me.
Liam was making that exact same point the other day. So,
yeah,
to some degree, we can, like the part that we showed in main.go, we can at least generate a really good snippet, right? Like we could
contributions.
So we can at least generate this for you, and then you can retrofit it to how you want to leverage, wasm in your project. But yeah, totally, like we can make this even more frictionless than it is.
Yeah, and this is another area where the line between waPC and wasmCloud is important, because in this particular Go host, it's sort of tailor-made for this particular WebAssembly file. wasmCloud is a generic host that will run pretty much any type of waPC WebAssembly module. It'll treat it as an actor in an actor model. And whereas here it's tightly coupled to a web server, when running in wasmCloud, that becomes a loosely coupled binding to a capability provider.
Okay, that's really interesting. So I'm super new to this wasmCloud piece, so that's where I need to learn. At the beginning of the discussion, I mentioned that I used to work at Google, and Liam mentioned Knative, and of course there's Cloud Functions. And when you talk to those runtimes, of course you don't, or when you talk to those services, you don't care about the runtime. You say, in this case, here's my rules engine WASM implementation, deploy it, and you let that service build the runtime for you, and then you worry about building the client to talk to it. So yep. I see that's what wasmCloud role is.
Yeah, that's very definitely what one of the key things that wasmCloud is trying to do. Also in the backlog for the curious, we are planning on building an OpenFAS gateway or an OpenFAS provider, so that you'll be able to run wasmCloud actors in a wasmCloud lattice, which is our mesh network, and then allow OpenFAS clients or regular HTTP clients to pass through OpenFAS and invoke your actors.
Nice. And I think there's some folks that are also on the Deus Labs Crosslet project as well. I assume that potentially that becomes a potential host as well, where you just throw it a Crosslet node.
Yep, that's not even potential. That's up and running now. So you can, using Crosslet, you can spin up a node in your Kubernetes cluster that is running the wasmCloud host instead of kubelet. And that way you can actually schedule actors directly to specific Kubernetes nodes.
Very nice.
Yeah, Daz, and they're on the call too if they want to chime in, or
Hi.
if you want to let Phil get through his demo, I would love to. We can open it up and just turn this into a discussion afterwards.
Yeah, let me wrap up. And we're almost there, right? So I showed you the curl command to run this business rule engine, right? And the income was 3,000. The credit score was 3,000 or 300. So, what if I decide I want to give out more loans and I'm willing to, relax my requirements a little bit? So I'm going to drop this down to 300. I'm going to drop this down to 3,000. So now that same request should work, right? So I'm going to do is say make build. And so that's recompiling my WebAssembly piece. And while that's cooking, I'm going to go grab the curl to really just call the reload. and says, okay, I did that. And so now when I do that, you don't see much because it's an empty array, which means I found no decision to deny this loan. So in theory, in your business process, you would continue and grant that money. So that is it.
Nice.
So real quick, let me just open up the call here. So when we wrote some documentation for this, we kind of broke this into 4 different steps, and I want to get some feedback to see, and especially for people that are just getting into the project. Jordan, maybe if you wouldn't mind, some feedback on this, or Milan. That there were 4 steps essentially to the CLI that happened here. The first was, editing the schema. If everybody followed along with that. And then it was doing the initial scaffolding, right, Phil? And then from the scaffolding, it was the process to auto-generate your libraries. And that was that make. So regardless of what language you picked, you typed make. And then this 4th step where the cake, just kind of came out of the oven baked was there was an application written around that. Was that clear in the demo on the call today?
Jordan, hey, yeah, no, I thought it was super clear. The one thing I missed, and Phil might have already had this prepared and I just missed that part, was the business logic piece, like the setting the 3,000, the setting 300. Was that just, you had that prepared somewhere, Phil, and then that was the magic bake? Sorry, that was the magic oven piece?
That was right at the end. So I'll go back to that, right? So the rules are here. They're underneath this rules subdirectory underneath the assembly directory, right? So here's where they're coded. So like if this was a real life use case, you got your rule authors and they can drop these rule files in, and then all that really has to happen is you have to wire them in. So you instantiate them and add them to the engine, and now they're there. So.
But the specific 3,300, that wasn't boilerplate. That wasn't generated for you. You had that already sitting there waiting.
Exactly. Yep.
Okay. Yeah. That. All right.
Cool. Thank you.
Sure thing.
Phil, you showed us the schema that you wrote. Would you mind showing us what, like, initially when you generated the assembly script, like index.ts, what that looks like just straight from generation before you implement anything?
Yeah, I'm gonna have to generate a new project for that, but you know what? I'll just do that for you right now. So you want an assembly script, right?
Yeah, I was curious about what it looked like from the rules that you wrote, or from the schema that you wrote, like in comparison to what you showed us with the example project.
Gotcha.
That makes sense.
So
Am I asking that right?
I think so. Let's get into it and see. Oh, darn it! I did it in the wrong place, of course.
So Brooks, are you looking for sort of a diff between the scaffolding output and the rules engine that he wrote?
Yeah, exactly. I just wanted to see what like the before index.ts file specifically look like in that rules_as project.
Okay, well, hold on. Let's just show you like what it generates right out of the box, right? Is this hello world kind of thing, right? So that's the whittle. And underneath assembly, right now there's nothing in there yet. So I have to go and say cd Brooks, and then I run make for the first time. And in theory, they're already there. So here's what the index TS looks like from the scaffolded point of view, right? So for every operation you have in your interface, it creates you a function for it, right? And it wires it up to the waPC handlers, if you will, there. And it does that for each of these operations you've defined. So if I said, you know, hello to, it would just create another one of these right underneath. And then the boilerplate is just the boilerplate. Like you're going to get that no matter what. That's just kind of how it works with assembly script, at least. So that's kind of the before. And I have to go back to the rules AS here. So I changed the whittle to this, right? And if I want to, yeah, actually for whatever reason, there it is. That's the like what it would generate for you.
Awesome. That's it. That's exactly what I wanted to see. I just wanted to see what it, from that whittle, what it looks like right when you like get it out of the box and you start and you are thinking about implementing it.
Yep. Do you have any other questions?
Phil, if you let me share my screen real quick.
Yep.
Thank you. So what I did was I took a really first rough pass, Brooks, at documenting a lot of that out. And if you look here to your question, this is before the make on the left side, and then this is after the make on the right side. When you look at, here's that new assembly directory with the module.ts, the tsconfig.json, and the index.ts. And then there's a ton of templates that get pulled down into the node modules directory. And then your wasm file that gets built out here as well. So I think in general, for anybody who's interested, there's a lot of opportunity to improve this based on today's demo. But I tried to do a basic hello world. I get all the way down to where all the ingredients are in the pan, and you need to put it in the oven and bake it. So what I did not do was then on the demo here yet was take that and write the Go code or whatever it is I wanted to write around it to use the scaffold that was built by the CLI. So that's the next step. And there are some great examples that Phil's already put out here with a Mandelbrot example, the rule demo that's there. And IBM is using this in their Hyperledger as well. So I think that depending on what you're interested in, seeing that there is other uses out there. And of course, there's the wasmCloud use case, which is the one that we're likely the most interested in. Real quick, any other questions for Phil or anything? Phil, that was a phenomenal demo today. Thank you so much for your time. And do we have you back again next week to talk about Whittle?
Man, you're putting the pressure on. I got to document Whittle really quickly, and then
I of course was trying to use the pressure as a forcing function, to stay up late and force myself to document it for you, and then get feedback from you or something along those lines. Look, we've got a few on the backlog. I'll maybe ask for a volunteer. We've got the Bindle potential demo coming up here, although I know that we wanted to touch base between the Pargeesies and Bindle for file format. And a few other demos here. So if somebody else wants to volunteer for next week, it would be much appreciated. Ralph, are you still on, or did you have to go to your next meeting?
I'm actually on.
Okay, you got anything?
Yeah, just a quick one. This is actually related to Daz's questions, the issue of Crustlet generally speaking. I noticed I dropped into chat the sort of the doc that shows how to get Crustlet bootstrapped. One of the issues that we were supposed to do end of last year was I was supposed to chat with Chris and get together and do the docs for bootstrapping on Critical Stack. And because of any number of reasons, mainly 3 weeks off, and then attempted coups, which I don't think were actually related to the Four Seasons landscaping. That was before Four Seasons landscaping. You'll notice I've cleaned it up a lot. So I'm just saying that I haven't done that yet, but added to that list, and probably the Critical Stack stuff too, we'll make sure that we have a nice, easy doc set on that. But so there's like 8 different assemblies or bootstrapping mechanisms and how you get Crustlet wired up. If Daz, you want to use Google, and you can use those as a sort of yeah, exactly. I was going to say volunteer to do a GKE one. That would be fantastic, and then wasmCloud can be dorked around inside Crustlet as a workload. That would be really, really cool.
I think all of those would be amazing. And Kit, I'll follow up, and Daz, I'll follow up with you guys offline, and we can just give you guys one on the schedule, and 2, talk about when we could do it, and how we can help you to help drive it forward, so that more people can experiment with more things in more places. It's the ultimate end by end, Phil. Back to our agenda. Let's see, community news. Wasm Time community meeting is next Thursday, 1/21. Meeting agenda is posted. Last week's meeting, we spent a fair amount of time working on some of the I would say project governance. We're talking a bit about, what does the patching policy look like? How do we organize all those sorts of things? And with the team transitioning into Fastly, there is some governance talk there, because they want to raise the bar and think about getting Wasm Time ready for the enterprise. Anything else anybody wants to mention in the general Wasm community? Okay, then on to our current, as we burn down the final .15 list here. Just a quick reminder that the new Azure registry is complete, and we've cut over to wasmcloud.azurecr.io. wasmCloud, the new website, is still in progress. We spent some time working on the CLIA stuff for this week, but on the general theme of getting documentation written, we could certainly use some help here if people want to help document. On actor interfaces, Kevin, anything to shout out here?
Yeah, sorry. Nothing really to shout out other than starting today, we're working on finishing out all of the Rust interfaces, and then we're going to try and build out a couple of the other interfaces. At the very least, for all the languages, we want to be able to run our canonical example, which is the key value counter. So for that, we'll need all of the languages to have the web server capability interface and the key value one. So those are all going to be available as part of the .15 release.
And Kevin, while you're chatting, you had documented some issues that I didn't get linked in here yet. What were those? You put them in Slack just yesterday or the day before? Was that anything current to bring up?
They weren't issues. I just started tracking some of the to-dos for the .15 release in the project in the org. Not really sure what the best way to track some of those is, because our milestones span multiple repositories. And so rather than using milestones, I've just used the project is org wide. It's not in a repo.
Got it.
And if anybody's curious at taking a look at it, it's public.
Of course, I'm pointing at my screen. That's awesome. Yeah, project.
This right here.
Yep.
Thank you. Magic of editing. I'll just go there magically.
Yep.
So right here, Kevin.
Yes, right there.
All right. So some a bunch of video things. The actor interfaces. Upgrade the actors, support all first-party actors and Rust, and at least 2 and Go.
Yeah, I mean it's basic release housekeeping. Publish everything.
So close on these. That's awesome. Just getting there. So Crustlet, you guys have an update. You guys are working on a new host. You're waiting till post.15. Is that right? Taylor, Radu, Matt?
Taylor. Look,
What
Taylor,
exactly?
I'm a PM. I don't know anything.
You're supposed to know these things. So
No, I ignore these things. That's what I yell at you for.
Anyway, yeah, no, we're not moving over. Basically, we have to move Crestlet over to the wasmCloud repo, the Crestlet provider for it over there, which I think we'll do first, and then we'll update all the wasmCloud stuff because we are woefully behind. But we're also trying to upgrade to like Tokyo 1.0 right now, and we need to update the kube libraries. So this is what happens when you're like heads down trying to figure out reverse engineering Kubernetes. So we'll get to upgrading those.
Okay. All right. That's awesome. And Kit. So ultimately, we should have a nice selection of providers in here. Daz, to your conversation. Kit's got his Lambda one, with the Crestlet one. If we can get a GKE one, that would be.
Turns out there is one. Daz is right. It wasn't in the list of in the doc file, but there is one in the repo, and so I'm fixing that doc right now. I posted it in the Crestlet channel in the Slack.
Okay, great. Awesome. So we had a few other things remaining open. We talked about the last few weeks. Bill, any update on packaging you want to mention?
Hey, yeah, so we actually did a bit of a pruning, I guess you could say, of the wasmCloud and wash packaging for AMD 64. Need to spin up an ARM instance so we can get those builds moving forward. That should be done this week. Outside of that, I think we're in pretty good shape.
Okay. And if anybody wants to test and give feedback on early packages, they're right here on wasmCloud. I'm not sure that this is actually linked anywhere on the project. I'll get this linked in and also pin it into Slack. And also we'll make sure that it shows up in the notes. Heading on down the list here. Kevin, any open PRs or issues that you want to highlight?
Now, we finished up the PR for the pluggable cache provider. So I don't know if everybody's aware of it, but the way the Lattice used to work, and by used to, I mean like last week, is that the state in the Lattice cache was being poorly replicated. And so now by default, if you start up the wasmCloud host without a Lattice, obviously the cache is isolated. If you start it up using the default system, it will use NAT's messaging to replicate the Lattice cache state. But if you want something more robust than that, you can actually just specify the OCI reference URL of a key value provider. And the wasmCloud will automatically use that for the Lattice cache. So if you want to switch between NATs replicated in memory to using etcd or console or Cassandra or anything else, you just give it the OCI URL of the key value provider, and it works like magic.
That's awesome, Kevin. And then on issues, just another quick call out here that there are a number of RFCs that are open that we'd love to get some feedback on here. Some of the things were mentioned earlier, but the JavaScript host runtime for wasmCloud, the Swift host runtime for the iOS platform, the supervision model, and Project Bandwagon. Kevin, I don't know, did you give anybody an overview on this one?
So that is yet another shameless attempt for me to shoehorn the ability to create a game engine with this technology. I'm going to make this happen one day, and I have no regrets.
YOLO. Okay. All right. Well, I think that is pretty much it on our backlog. We've got a number of demos here. I'll collaborate with the volunteers to see if what the schedule looks like for the next 6 or 8 weeks or so, because I think that's what we've got demos laid out for. I also want to put out a call to action with the .15 release. We're going to do another tasting. This will be all are welcome to this one. So watch for an invite on our Slack, and I think you guys know the drill by now. I'd like to get this one on the books maybe 3 to 4 weeks out, so we make sure we've got enough time for shipping. But we can do another bourbon tasting, or if anyone has another volunteer for a little hangout celebration or a suggestion for what they'd love to do, just let me know, and I'm happy to help facilitate and organize it. I'll open it up to everyone on the call. Jeff, anyone that we didn't hear from yet, or Gustav, any questions, comments?
No, just a super interesting demo to see. Super interesting demos, and yeah, looks cool.
Awesome. All right. Well, thank you, everybody. I'm going to go ahead and stop recording, and we can all hang out. But have a great week.
Since I've looked at interface types, it's an ever-changing spec. You know, I guess I'm trying to infer what Kevin's alluding to, but there are kind of memory allocation semantics that are going on there. Not to mention like the lift and lowers. I'm kind of curious about how that works, going back and forth over the FF boundary numerous times. That's how you make systems really slow, is like the death by 1,000 cuts. And so, you know, I mean, you know, the fact that shared memory is in there, and maybe there's a way to mitigate that. The fact that it's all controlled through wasm time. I'm kind of just waiting to see how it turns out, to know like how it's going to function and what the mechanics will be. So I've kind of been tuned out of it, to be quite honest, until I see something real, which, I mean, Raidu, that's kind of what I was interested in hearing from you, as you are in the wasm time, using the interface types as they exist right now and doing your research based on that. Is that true? Like the byte passing that you're doing, that's the wasm time specific stuff? Or
I don't think I'm in a place where I can confidently answer that question about interface types and either. So I kind of need to do some more digging into that as well.
Yeah. So
let alone in a recorded call.
I guess the high level summary of what it is I'm talking about is, when you use some of the generating stuff like wasm bindgen or and things like that, what you end up with is these shims in JavaScript where you can create an object on the host side, which is a pointer to an object on the guest side. And the thing that makes that scary for me is that pointer lasts longer than one method call, which means you now have a stateful WebAssembly module, because that pointer needs to essentially guarantee that the data that it points to hasn't either been moved or destroyed. And while that's perfectly fine in certain languages, you know, Rust can pin the pointers and things like that, but then you have languages that have garbage collectors on the inside or things like that. And you know, part of what we're trying to do with waPC is not only be language neutral, but engine neutral. So it needs to work with more than just wasm time. And again, it needs to be stateless. So with waPC, it's designed specifically so that I can make a method call, and after I make that method call, I can completely destroy the WebAssembly module and reconstitute it from scratch and have no negative consequences. And so what remains to be seen is whether that same type of stateless guarantee is something that we'll be able to have with interface types. If we can't avoid explicit memory allocations or long-lived pointers or accidental statefulness with interface types, then waPC will probably not end up using them.
Right, but all the memory allocations are eventually made in guest memory, which is associated with an instance. So once you shut the instance down, then the host should deallocate its memory, its linear memory anyway. So if you recreate it, theoretically, you should get a new array of bytes as its linear memory, in theory.
Yeah, so there's some in the weeds discussions to be had there, but I guess the takeaway there is that interface types isn't something that is an automatic adopt. It's a once the spec stops changing and there's an implementation in wasm time and there's an implementation in another engine other than wasm time, then we can look at that and see if it still meets our needs.
Yeah, that makes complete sense. I don't think anybody else in any other app model or runtime will be using any different algorithm than that.
Yeah, Kevin wants pass by value, not pass by pointer, right? And so, you know, we're making copies. And so, you know, right now, waPC is making at least 2 copies, right? Once there are things like shared memory and some of these specifications start to make it to the languages, like if there's shared memory, we can, in theory, eliminate a memory copy hop, if you will, right? And make it more efficient. So I think there's going to be like baby steps at achieving the ultimate goal over time.
Yep. And again, part of the reason why waPC exists as an abstraction is so that when you're using waPC, you don't care whether interface types are being used underneath it or not. And when you're using wasmCloud, you don't care whether interface types are being used underneath waPC.
Yeah, as long as the guest and host agree on the serialization format, then you can use it. So, which is obviously a good thing. I think we can discuss some more about the actual memory allocation things. I'm not sure everyone on this call is interested about that, so I'll stop here.
I don't know. I think the outside of the ringing that I have right now, I think that. Sorry, I've got like too many browser windows open here to find my phone. 1 second. I think that there are people on this call that would enjoy it, and I think us, kind of documenting it together and writing it down is super valuable. Like what you're doing with your blog post, Radu, is amazing. And there what we continue to find is that there's just a huge number of people that are all stuck at the same spot, and we as a team could do a much better job on sharing some of that knowledge and and putting it all out. So I think that if somebody wants to, do a walkthrough here or maybe review this in detail, this make a great topic to record and just put out there so that people have as of January 2021, here's where we're all stuck on this and here's what we're doing to get around it. So I mean, my 2 cents on it.
Yeah, I don't necessarily mean to do shameless self-promotion. Actually, yeah, I do. The edX class that I'm working on for Linux Foundation has a chapter in it that goes into excruciating detail on the various different ways that you can do guest and host memory sharing and copying and where statefulness happens accidentally and intentionally and things like that.
Looking forward to that.
Sounds great, Kevin. I'll look forward to it. Any other topics we want to throw out?
Hey, Liam, one thing on the admin side, color theory and logo voting. Are we gonna try and set an estimate date on those, or is this group gonna be, sorry?
Not at all. No, Kevin and I touched base a little bit on did we want to put it out on Twitter and let people vote for it, or put it out on Slack. You can kind of see the basic of what we picked. If you look, there is a wasmCloud up on LinkedIn. Give me just a sec. I'll pull it up here. This is an ugly version of the logo. I only posted this just because I was doing there's a press release that went out this morning around another project that I work on. But the logo will be kind of, octagon-y, and it'll look like that. I guess don't even look at this. Doesn't even matter what I've posted up there. So we'll get the color scheme done. We're going to go with something that's in the blues. I don't know if we'll do a triadic color pattern or a biadic, but something that's the root will be blue. And the reason for that is we wanted emotionally calming and chill. We thought after 2020, everybody would want a platform that, communicates calm and, stable, like the ocean. So that's where I think we're going to end up. And I'm just behind on handing the work off to a graphic designer just to finish up. But hopefully, I don't know if we have a date planned for the .15 release. It's sometimes helpful to drive towards a date. Maybe we can pick one out together on Slack, and I'll try to drive towards a date because we're close. So you can see everything all getting wrapped up here slowly. We're just so close on .15. Honestly, documentation is probably the biggest milestone we have.
Cool. Yeah. And as far as that goes, I mean, since I'm trying to put the documentation together, I don't know where all that's living, but God damn it. As that's being done, if y'all just want me to start plugging it into the working website to see the documentation updating as it goes, I can do that.
Yeah, you can just relink it in Slack. That'd be great. It's all tied up in Netlify, and we'll go from there.